My name's Paul Sereiko. I'm the Director of Marketing and Product Strategy for the FieldComm Group. And I'm going to talk to you a little bit about today about OPC UA and information modeling in the process automation industry. And I'm subbing for our President and CEO, Ted Masters, who unfortunately could not be here today because of a prior personal engagement. But I think I'll communicate it pretty well. I'm going to go through a few things. First, I'm going to go through what is FieldComm Group. Many of you might not know who FieldComm Group is, particularly if you're not engaged in the process automation business. I'm going to talk about how FieldComm Group and the OPC Foundation have worked together quite successfully over the years. I'm going to discuss how Industry 4.0 and IIoT affect the process automation industry. And lastly, I'm going to talk about how suppliers are collaborating to address end-user needs with foundations and other organizations. I'm going to kind of mix these topics up during the presentation, so it's not going to be a perfect flow, but hopefully you'll get the gist of it. FieldComm Group. FieldComm Group, we like to call ourselves the home of process automation. We're a member organization. Global. We have about 370 members worldwide, and those members all make process automation devices, host controllers, or software that use our technologies. We're the home of two relatively mature technologies, the HART communication protocol and the Foundation Fieldbus protocol. And when we were formed as the result of a combination of those two organizations back in 2015, a new technology called FDI, or Field Device Integration, was added into our portfolio. And FDI, Field Device Integration, is an OPC UA-based technology, and I'll tell you more about that during the course of this presentation. Many of you are probably aware of the older technologies that we've had. These HART and Foundation Fieldbus have been around for 20 plus years. There's probably 50, 60 million HART devices installed in process plants around the world. A lot of companies have centered on Foundation Fieldbus. In fact, the Shell Prelude, which is the world's largest floating liquid natural gas facility, has several thousand Foundation Fieldbus control loops installed and in operation on a vessel that's parked a couple hundred miles off the coast of Perth, Australia. We've been working with the OPC Foundation for a long time. Back in 2004, we worked together on a specification called EDDL. EDDL is the language that is used to communicate, to create device drivers for process instrumentation in the process automation industry. But we've really been working quite closely with them since this 2011 to 2019 timeframe, and that's when a lot of activity has taken place, largely as the result of emerging IT standards and protocols like in the industrial Internet of Things and things like that, Industry 4.0, of course. We started working with the OPC Foundation as well as Profibus in FDT on the FDI specification back in 2011. One of the first things we did there was we co-authored the device information model, which is a companion spec to OPC UA. And that spec became the basis for the FDI technology that we now, that many of our members now include in their products. To take that to the next step, beginning in 2017, we started working on a new information model that we call the Process Automation Device Information Model, or PA-DIM. And you'll be hearing me talk about PA-DIM a lot in the next few minutes of this presentation. PA-DIM is something that we started working together on in 2017, and later this year we should have the first demonstrators available of PA-DIM technology. So what kind of work have we done previously with the OPC Foundation? Well, as we all know, anybody in this room that works on OPC UA, they understand the layered approach that you take. So, the OPC meta model, defines the basics of OPC. And then on top of that are various information models and companion specifications that hone the base core model to specific industry applications. We worked on IEC 62541, the device information model. We co-authored that with the OPC Foundation. We created a companion specification for FDI, and I include that along because it's at the same level as other companion specifications that have been created using the OPC UA modeling language. And we're now working on PA-DIM, the Process Automation Device Information Model. So what is PA-DIM? Well, PA-DIM is an effort to standardize and specify an OPC UA information model for the process automation devices that includes semantic IDs or machine-readable IDs for various parameters associated with the device. As I mentioned, we began working on this late in 2017. We're doing this in a coordinated joint working group that FCG, FieldComm Group, and OPC Foundation jointly participate in. And the idea is to create a standard device model targeted specifically at the process automation industry. And this is being supported by end-user organizations like Namur and the Open Process Automation Foundation, and other standards organizations like Profibus, Profinet International, ZVI, et cetera. But the reason we're doing this and why we're doing this, why we're creating PA-DIM, kind of goes back to the Namur open architecture. You're all familiar with Namur in this room, I'm sure. But the Namur open architecture is a way that Namur would like to see the next generation process automation systems adapt to IoT and Industry 4.0 without deviating from what's been successful in the past. And what's been successful in the past in process automation is this hierarchical approach where you have things, field device instruments, controllers, field device instruments and things like that on the bottom layers, controllers and communications on the top, and then IoT platforms and human interfaces at the very top of the architecture. That's great for managing a control system, but it's not necessarily the optimal architecture for monitoring and optimization and advanced analytics and things like that. So Namur, as part of the open architecture, has proposed the addition of, we call it the wedge, which can interact with all of these layers in a secure way, in a unidirectional way, frankly, and in an open way. And the technology for building that is the OPC UA technology, and that's what PA-DIM is kind of all about. From a more technical standpoint, a way to look at the Namur open architecture is in gray. You see the stuff that is in the core process control environment. And this is where FieldComm Group has traditionally operated, and this is where most process automation companies have traditionally operated. They operate in these green lines where there's communications between a field device and a DCS or a PLC and a control system. We don't typically operate in these lines in the process automation business, and in part because there are some challenges that are unique to the process automation business, but Namur has given us a challenge to figure out how to address these red lines, if you will, and we've come up with some solutions. But first, let me step back and talk just very briefly about some of the challenges in the process automation industry. First of all, as you all know, this is a continuous flow industry. Field devices are typically installed for 15 to 20 years. They never want to be replaced. And because of that lack of replacement and a long life cycle, device integration and replacement tends to be a challenge. Also because the process is always running. It's a continuous process. It's not like you can shut something down and take out an instrument and put in another one. It's difficult to do. These are real-time systems, and they're real-time systems that have a very high consequence of problems if they don't operate. When a process facility goes bad, it goes bad in a big way. There can be environmental disasters, loss of life, certainly economic disasters. So the requirement for safety, security, and continuous uptime is enormous in the process automation industry. The processes themselves typically don't change that quickly, and the technologies that had been developed to address the process industry fit the need very well. But needs are changing. There's a need for more information. There's a need for access to information from other actors, and this is how we have to move the industry. We also have a lot of proprietary systems in the process automation industry. Obviously, openness is great as long as it's open and it works, but vendors for a long time have sold proprietary systems to provide that level of security to the customer that they might not have with open architectures. That's changing. Products typically have to conform to standards, highly developed standards, highly developed test specifications as well. So there's some solutions to some of these challenges. First of all is an OPC technology, that OPC-based technology, FDI, that I'm going to speak about, that brings digital twins into this environment so that it's easier to install and swap out a device than it was before. The additional needs for speed in terms of new applications and things that information from the devices, lots more information from the devices, is resulting in the development of a new physical layer and architecture to go along with that. It's called APL. It's something that FieldComm Group is working on with ODVA and with PI, and there's a number of companies in this room, suppliers in this room, who are championing this technology. It's a 2-wire Ethernet technology, 10 megabits per second, with power running over the line that can be installed in intrinsically safe environments. And that's going to add a lot of, cause a lot of changes in the process industry. To address the needs of open systems, or to enable more open systems, we're working with the OPC Foundation on the PA-DIM model. And we're also building common host components that the host controllers can build into their system so that there's a base of code that is reliable and easy to use. And we'll always be adding more conformance as well. So these solutions bring on new opportunities. They're with a shared communication infrastructure. That's a great thing, because now over a single wire you can be running a lot of different protocols that might have different needs. But it also means that you need to make sure that every protocol that's operating on that physical wire has the quality of service that's needed to maintain its real-time control requirements. When you put IP devices down on the plant floor in a place like a process control facility, there's a lot more security implications than there were with technology that you could not reach through an IP address. So there's security opportunities that are going to emerge as these new architectures take hold. And kind of the theme of today is there's also a great opportunity for harmonization, for standards harmonization between process automation and factory automation. And I would encourage everybody in this room that's working on one of these standards committee to work together and make sure that we can create a common information model that works across industries. And I'm going to explain a little bit about how that might be done in a couple slides. First, couple things on FDI, just to give you an example of technologies where OPC UA is already available in commercial products, host systems, field devices, etc. FDI technology is that technology. It's been around for a couple of years. FDI is basically a way of virtualizing physical devices in software, storing instances of those devices in an FDI server that sits in a process facility, and then through client applications bringing that information out to users that might need to use it, whether they're mobile, in a plant, as an operator, etc. Digging a little deeper, FDI technology is not just a FieldComm Group technology. We support all of these protocols. In fact, there's co-ownership with several of the foundations. So Wireless HART, HART IP, Profibus, Profinet, Foundation Fieldbus, Modbus, ISA 100 Wireless are all supported through FDI. by virtue of an OPC UA interface. The server in an FDI server also is built on OPC UA. So it's a great, it's a great technology, and we've been using it, and our members have been building products around it for a few years now. The next step that we need to worry about is opening up this interface between the servers, the FDI systems, and the rest of the world, the cloud applications, if you will. And that's what PA-DIM is all about. Because open information models, which are hopefully a little bit more descriptive than all of these bits and bytes flowing across the screen, which is what standards organizations have typically been in charge of. Open information models can enable new HMIs, simplify the development of HMIs, simplify the creation of analytics applications and cloud applications, and even add process control, even improve and simplify the development of process control algorithms. So we need information models. That's the bottom line. We need information models above and beyond communication protocols. So let me summarize just a little bit on PA-DIM and where we are. So PA-DIM, in its current instantiation, the specification is being balloted, will be balloted soon, and the first release will be done soon. But the purpose behind PA-DIM is to build an information model using an existing EDD package. There's lots of people in the industry that know how to use EDD, EDDL. So if we can leverage that basis and use that to create a PA-DIM model, that's a great thing. We also, in its initial instantiation, need to be able to support the existing field device protocols, HART, Foundation Fieldbus, Profibus PA, et cetera, because as I mentioned, the instruments in this business have 20 to 25-year life cycles, and they're still being shipped, and they will be shipped for a long time. So we need a solution that can take advantage of the new without sacrificing the old, and we're going to do that, and we're doing that in our working group through some mapping algorithms for PA-DIM. But ultimately, wouldn't it be great if we could take that PA-DIM model and push it right down onto a field device? Now, obviously, there's a lot of issues associated with that. Some of the field devices don't have a lot of processing power, don't have a lot of security. So there's things that we need to consider, but these are things that we are considering in FieldComm Group working groups with a goal towards eventually having native PA-DIM devices that could run on this new Ethernet APL physical layer, thus enabling protocol independence up at this layer for all of the applications. Okay, and we think that would be a great thing. How do you go about doing it? Well, you rely on standards. There's standards everywhere, right? Standards are great. That's why there's so many of them. There's IEEE standards that we need to rely on. There's OPC Foundation standards that we need to rely on, that we need to work, and OPC UA information models that we need to work on. But ultimately, at the very top layer, there needs to be a device information model that might be customized for some of the specific market applications, whether it's process automation or an I/O device in factory automation or drive in factory automation. But they need to all rely on the underlying tenets of OPC UA and some of the foundational companion specs that have been put in place before. So there's a great collaboration opportunity here for factory automation and process automation, and I hope we can take advantage of it. We have a white paper on this. You can download it there if you want to if you want to get the QR code. It's a great white paper that was written mostly by Achim Laubenstein, who works for FieldComm Group, as well as ABB. And it really tells a lot about process automation and device information models and why we need them. Current press update. We have some new collaborations on PA-DIM that we announced recently. It's been endorsed by Namor, as you can probably gather from this presentation. It's been endorsed by the Open Process Automation Forum. Namor and ZVI are working on how PA-DIM can operate within Namor open architecture through some FCGA liaison work that we're doing. PNO is obviously involved. And our goal is to finish up the specification and then do a demonstrator at the next NUMOR General Assembly of the first iteration of PA-DIM. It's very exciting. Follow what we're doing. Thank you very much.